Alright, guys and girls, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom with me, Coach Goo. Can't be loud here because it's a little late over here, so let's get into Unit 13, Notes number 1, Multiplying and Dividing Radical Expressions. Alright, so first of all, this goes back all the way to Unit 8.5 where we had, radicals, radicans, indexes, absolute values. All right, but there's two new rules that we need to know first. And one of them is if the exponents, let me write this down. All right, if the exponents are the same, you can simplify by multiplying the bases. And what that looks like is if you had something like this, hold on, 2 to the third times 3 to the third. Notice both the exponents are 3, so we can simplify by just multiplying the bases. So this is the same thing as 2 times 3 raised to the third, which is actually just 6 to the third. All right, and now for the next rule. If the indexes are the same, you can simplify by multiplying the radicands, or what is under the radical. For example, if you have the cube root of 4 times the cube root of 5, notice the index on both of these is the 3. The index is 3. So this you can simplify by just saying this is the same as the cube root of 4 times 5. Or, oh my gosh, my eraser's not working. This is the same as the cube root of 4 times 5, which is the same thing as the cube root of 20. Alright, so let's try some examples using those two rules we just learned about. Okay, so first of all, it says simplify the products of the following radical expressions if possible. If not, explain. Alright, so on A, can we actually multiply these two? Yes, we can, because they have the same index. Both of them have an index of 3, so this is going to be the same as the cube root of negative 8. Now, what is the cube root of negative 8? So we're looking for a number, and when it multiplies by itself 3 times, that gives me negative 8. And what would that be? Is not 2, because 2 times 2 times 2 is positive 8. It would be negative 2. So the cube root of negative 8 is just negative 2. So the answer here is negative 2. Now look at B though. B is the 4th root of 7 times the 5th root of 7. Now we can't do this. Why not? Because the indexes are different. Right, one's a 4 and one's a 5. They have to be the same to be able to do this. All right, so then look at C. The 4th root of 8 times the 3rd root of 32. Once again, exact same answer, because the indexes are not the same. One has an index of 4, one has an index of 3. They have to be the same. All right, D. The cube root of negative 5 times the cube root of negative 25. Okay, the indexes are the same, so we can actually just simplify by multiplying. So this is going to be the cube root of negative 5 times negative 25, which is positive 125. Now, what is the cube root of 125? What times itself 3 times gives you 125? That would be 5. 5 times 5 times 5 is 125. So that means the cube root of 125 is indeed 5. There you go. There you go. And lastly, E. The cube root of 16 times the cube root of negative 4, we can see that the indexes are the same, so we can simplify by just multiplying the radicals. So this is going to simplify to the cube root of negative 64. And what is the cube root of negative 64? That is going to be negative 4, because negative 4 times negative 4 times negative 4 gives me negative 64. All right, so now we're going to, this is now we multiply and put it all together. So we're going to look at some more complicated rules, or some of the rules that you may have forgotten from Unit 8.5. So let's do this. First of all, we see that these two terms, the square root of 72x cubed y squared times the square root of 10xy cubed, it has the same index. Both of them are the index of 2, the invisible 2, right? Boom, boom. So we can multiply these. So let's multiply them. When we multiply them, what do we get? We get the square root of 72 times 10 is 720. And then what happens when I multiply variables? We add the exponents. So x cubed times x is x to the fourth. And y squared times y to the third, we add those exponents. 2 plus 3, so y to the fifth. All right, and now we have to simplify this. So when 720, we want to break it down into a perfect square. So if you don't know what makes up 720, it's going to actually be 144 times 5. All right, 144 is a perfect square. And then we have x to the fourth, y to the fifth. So what's going to come out of my radical? This is a square root, right? So what is the square root of 144? That's just 12, so I can pull the 12 out. Now it's not under the radical anymore because I just pulled it outside of the radical. Next, what is the square root of x to the fourth? How do we simplify radicals with variables? Remember, whatever the index is, so the index here is 2, divide the exponent on the variable by that index. So 4 divided by 2 is 2. So that means on the outside I'm going to have an x with the power of 2. And I have nothing left on the inside. There was no remainder. Okay? Next, y to the fifth. So I'm going to take 5 divided by 2. And what goes into 2? So 4 minus 1. The remainder is 1. Okay? So on the outside it's going to be y to the 2. That is this 2 right here. And on the inside of my radical, what did I not use? I didn't use this 5. So this 5 is going to go, let me just use different. So this 5 is going to go down into the radical because I haven't used it yet, and there's no square root of 5. And then what was my remainder? I have y squared on the outside. My remainder here was 1 when I tried to divide. So on the inside, I'm going to have y to the first, or just y, because the remainder was 1. Boom. All right, so this is my answer right here. 12x squared y squared square roots of 5y. Whew. What a doozy. All right, let's try some different other examples then. So more examples, example J. Okay, so the indexes are the same. They're both square roots, so we can multiply. So this is going to turn out to be, what is 4 times 8? That's 32. X fifth times x is x to the sixth. And a y times y to the fourth is y to the fifth. I just added the exponents on the variables. All right, so we're going to look and see what makes up 32. So I want a perfect square because I'm dealing with square root. So what is a perfect square that would be a factor of 32? That would be 16 times 2. Then we have x to the sixth, y to the fifth. Okay, so let's see what we can take out of the radical. What is the square root of 16? That's going to be 4. All right, x to the sixth. So my index is 2, right? So I'm going to take the sixth divided by 2. That's 3. So now on the outside, I'm going to have x to the 3. Now I have y to the fifth. So I'm going to take 5 divided by 2. That's 4 with a remainder of 1. So on the outside, it's going to be y squared. And left on the inside of my radical, what did I not use? I did not use the 2. So the 2 is still on the inside. And the y, when I divided the 5 by 2, I had a remainder of 1. So on the inside, it's going to be y to the first, which is just y. So my answer here is not complete yet because, remember, this is an even index. And on even indexes, we're just looking for the positive answers, right? So in order to make all of these answers positive, I have to put absolute values around my odd exponents. So this is a rule that we learned back in 8.5 that we may or may not have forgotten. So when you have an even index, you have to put the absolute values around the odd exponents in your final answer. That is to make sure that your answer comes out positive. So there we go. All right, now k. So we got the same index. It's a square root, so we're going to just multiply. Just going to multiply these together. That's going to give us 24. 8 times 3 is 24. X squared times x is x cubed. And then y to the 6th times y to the 4th is y to the 10th. All right, so let's see. What factors make up 24 with a perfect square? That's going to be 4 times 6, x cubed, y to the 10th. Now, what's the square root of 4? That's going to be 2. And now let's see, what can I pull out with the x cubed? That's just going to be 1x outside with 1x remaining on the inside. Then y to the 10th, so 10 divided by 2 is 5, so we got y to the 5th. All right, and what else did I not use? I didn't use so I already took care of the 4, I already took care of the x cubed, I already took care of the y to the 10th. What did I not use? The 6, so the 6 is going to be on the inside as well, so it should be 6x on the inside. Now notice, remember this is an even index, it's a 2, and my odd exponents are both of these terms. The x has an exponent of 1, the y has an exponent of 5, so both of those terms need absolute value signs around them. Boom, that's my final answer right there. All right, 2 more multiplication examples. So L, okay, we're going up into a higher index now. So it's both are cube roots, so we can multiply. So cube root of 9 times 3 is 27. X squared times x to the 4th is x to the 6th. Y times y to the 7th is y to the 8th. All right, let's see here. So right here, at the beginning, I can see it's an odd index. So I don't need to worry about absolute value signs with odd indexes. Okay, so equals, what is the cube root of 27? That's 3. Okay, 6 is the power on my x, and my index is 3. So I just take 6 divided by 3. There's no remainder. 6 divided by 3 is 2, so I'm going to have x squared on the outside. Okay, so I took care of the 27, took care of the x to the 6th. Next, y to the 8th. What's 8 divided by 2? Or 8 divided by 3, because the index is 3. 8 divided by 3, 2 minus 6. Remainder of 2. So on the outside, I'm going to have y squared, and on the inside, I have the remainder of 2. And right here, don't forget to put the cubed as the index on the radical, because otherwise it's a completely different answer. There you go. Boom. 3x squared, y squared, times the cube root of y squared. And on to the last one, m. We're looking at the 4th root, so, galaxy pen. 4th root, multiply 2 times 8 is 16, and then x times x to the 7th is x to the 8th, and y to the 4th times y to the 6th is y to the 10th. Alright, so now let's try to find out the 4th root. What is the 4th root of 16? 2 times 2 times 2 times 2 is 16, so the 4th root is 2. Okay, I'm going to go ahead and write the 4th root symbol here so I can separate what's inside and what's outside. So 16, that's gone. Okay, now x to the 8th divided by 4. So I take the power, which is 8, divide that by 4, that's 2. So on the outside is going to be x to the 2. And there's no more x to the 8th term. This is gone. Now y to the 10th, I have to take the 10 divided by my index, which is 4, and see what my remainder is. So that's 0, 2, minus 8, so 2, the remainder is 2. So that means on the outside I'm going to have y to the 2, and on the inside I'll also have y to the 2 because I had a factor of 2 and a remainder of 2. And so here's my final answer. I don't need any absolute value signs because there are no odd exponents. So this is my final answer. 2x squared y squared times the 4th root of y squared. All right, and now moving into the second half right here, we are going to be doing some division. And so the rule here is if a and b are real numbers and b is not equal to 0 because you can't divide by 0, then pretty much what it's saying is if the indexes are the same, then you can just divide those two numbers as usual. Some tasty water. All right, so let's try some examples. So number 1. I can see on number 1, the indexes are the same. They're both square root, which means I can just divide those numbers. 200 divided by 4. So this ends up being the square root of 50, which is, what makes up 50? 25 times 2. What's the square root of 25? That is 5. So 5 square roots of 2 is my answer on number 1. Boom, there it is. Number 2, both, again, are square roots. That means I can divide. So what's 18 divided by 2? That's 9. What's x to the 5th divided by x to the 3rd? When you're dividing variables, you just subtract the exponent. So 5 minus 3 leaves me with x squared. So now, what is the square root of 9x squared? So square root of 9 is 3. And then with the x squared, all I have to do is take 2 divided by the index of 2. That leaves me with just x. 3x. However, remember, this was an even index, and I have an odd exponent, which means I need... Whoa, I don't need that. Don't need any of that. 3, I need absolute value bars around my x. There's my answer. Number 3, same thing, right? Oh, they already started off like this. This is the same thing as 36 divided by 2, which is going to be 18. And then x to the 5th over x. So 5 minus 1, the exponent 1 here, leaves me with x to the 4th. But then the y squared on the bottom, there's no y's on the top. So on the bottom, we're just going to leave the square root of y squared. Okay, so let's try to simplify a little bit. So on the top, what makes up 18? 9 times 2, and then x to the 4th. On the bottom, what's the square root of y squared? That's just y. However, remember we need to put absolute value bars around this because we started with an even index, and this is an odd exponent on the y. Alright, so now we're going to simplify the top part. What is the square root of 9? That's 3. And x to the 4th, I can pull out x squared, because 4 divided by 2, the index, is 2, so x to the 2. What was left? Just the 2 that I did not touch, and then over the absolute value of y. So this should be my final answer. 3x squared times the square root of 2 over absolute value of y. Alright, number 4. Let's divide, because it has the same index. So this is going to be the same thing as the square root of 24 divided by 2 is 12. C to the 5th divided by c is c to the 4th. And d to the 5th divided by d cubed is d squared. Okay, so this should work out pretty nicely because 12 is 4 times 3. Then we have c to the 4th, d squared. So let's see what we can take out. What is the square root of 4? That's 2. So 4, be gone. What did I not use yet? The 3. Now I've used it. C to the 4th, what's going to come out? C squared. So now that one's gone. D squared, what's going to come out? Just d to the 1st. And so now I've dealt with all the terms and I'm done. My answer here is 2c squared, absolute value of d, times the square root of 3. Alright, number 5. Okay, so we're going to divide. This is going to be the cube root. Don't forget the cube root. That changes it completely. 250 divided by 2 is 125. And then a to the 7th divided by a is just going to be a to the 6th, because 7 minus 1 is 6. B to the 8th divided by b to the 4th is b to the 4th, because 8 minus 4 is 4. Alright, so now we're just going to deal with this. So what is the cube root of 125? That's 5, because 5 times 5 times 5 is 125. And now the cube root of a to the 6th. Well, what's 6 divided by 3? That's 2, so on the outside, a squared. So I've dealt with the 125, dealt with the a to the 6th. B to the 4th, 4 divided by 3 is 1 with the remainder of 1. So on the outside, b to the 1st. Cube root, what did I not use? B on the inside as well. Because as I said, 4 divided by 3 is 1 with a remainder of 1. And so this is your final answer. You don't need to worry about absolute value signs because the index was odd. 3 is odd. And second to last one right here, another cube root one. Oh, this one looks funny. So we can just simplify. So simplify by dividing. So the cube root of nothing on the radical on the inside. So 8, we're just going to leave that there. X cubed divided by x cubed, those cancel out. So there's no more x cubed. Y 7th divided by y is y to the 6 over 2. All right, because I've canceled, I've used everything on the bottom. Okay, so now what is the cube root of 8? That's 2. And y to the 6th, so if I take 6 divided by 3, that gives me 2. So y squared, nothing's left on the inside of the radical, over 2. And so now I can reduce by canceling out the 2's. And that leaves my answer as y squared. Alright, and now we're on to the very last one. So let's divide first. 162 divided by 3, cube root of 54. And then y to the, y to the 5th divided by y squared is y to, wait, what the? I wrote an R on accident. Is y to the 3rd, because 5 minus 2 is 3. Alright, so then right here, what do we need to do? We need to see what is a cube, a perfect cube in 54. And that's actually going to be 27. So 27 times 2 makes 54. Then we have y cubed right here. So what is the cube root of 27? That is 3, because 3 times 3 times 3 is 27. Okay, so goodbye 27. And then y cubed, 3 divided by this 3 right here is just 1. So there's going to be y to the 1 on the outside. So this y cubed is gone. And what's left on the inside? Cube root of 2, because I didn't use that 2. So there it is. And this is my final answer. 3y times the cube root of 2. Alright, and that is going to conclude this section of notes, guys. So I'll see you tomorrow when I'm back. But until then, see you next time. Peace!